Good afternoon, ma'am.
Good afternoon, ma'am.
Warm welcome, ma'am.
Thank you so much, ma'am. Thank you.
Good afternoon, ma'am.
Yeah, sir. Good afternoon,
Please
sir.
welcome, ma'am. Welcome, please welcome.
Yeah, thank you so much. Thank you. Thank you for inviting me to be a part of your conference. It's my pleasure to be with you. So,
Yes, fine.
thanks.
Good afternoon to one all present here. A warm welcome to all the participant, research scholars, and all the person in there. I request all the participant to mute your audio and video during presentation. You can unmute the audio when you are presenting your paper and while asking the questions. Okay, we need your kind cooperation. Okay, so totally for each paper we'll be allotting a 15 minutes. After for presentation 12 minutes, for question and answers like you have it, for queries you have 3 minutes. Kindly mute your audio and video when you are in the meeting, when others are presenting. The link for the feedback will be displayed at the end of the session in the chat box. For getting a certificate, feedback is a compulsory. Okay, I call upon Mr. Dr. Komadinayagam sir to welcome the session chairpersons. Sir.
Thank you, ma'am. Good afternoon to one and all present here. It's my immense pleasure to welcome and introduce our external session chair, Dr. S. Tangaramya, ma'am. She is an associate professor in the Department of Computer Science and Engineering, RMK Engineering College, Chennai. She obtained her BE CSE from Dr. Sivanthi College of Engineering and MS by Research from Anna University, Chennai. She has obtained PhD in Information and Communication Engineering from Anna University, Chennai in 2017. She has been in teaching profession for the past 20 years and has handled both UG and PG program. Her areas of interest include programming languages, database management, cloud computing, and data mining. She has published 24 papers in various international journals and conferences. She has also published 4 textbooks for benefit of the first year BTech students for Anna University. She has got Oracle Java International Certification, IBM RAD, Tivoli, and DB2 certification, and obtained her PRP certification from Wipro. She secured bronze medal from Infosys for a Campus Connect program. She is the life member of ICSTA. Thank you, ma'am, for accepting our request and to become a session chair for this session. And welcome you, ma'am, once again.
Thank you, sir. Thank you.
Next, I introduce our internal session chair, Dr. V. Anisha, ma'am. She is an associate professor in the Department of Computer Science and Engineering, Ramco Institute of Technology, Rajabalayam. She obtained her BE CSE from Sivanthi College of Engineering, ME CSE from Government College of Engineering, Tirunelveli. She has obtained her PhD in Information and Communication Engineering from Anna University, Chennai in 2020. She has been in the teaching profession for the past 22 years. Her research interests include medical image processing, data science. She has published 29 papers in various international journals and conferences and published 1 patent. In addition to that, she has completed online courses and attended FTPs on emerging technologies. She is the life member of ICSTA. Thank you, ma'am, to become a session chair for this session. Once again,
thank you, sir.
Next, I will call upon the research scholars to present their views in this forum. First of all, I will call upon paper ID 187, titled on Indian Sign Language Recognition System by Kanchan Patel. Ma'am, please share your screen and you can present your.
Yes, sir. Yes, sir. Poonam, please share the screen.
Yes, ma'am. My screen is visible?
Not yet.
Mayuri, can you share your screen, because this share screen option is disabled for me.
Yes, my screen is visible.
Yes, it is.
Yes, it is visible. Shall we start, ma'am?
Yes, ma'am. Yes, of course.
Yes, sir. Thank you, sir. So, good afternoon, one and all present over here. We, the student and professor from Sanjani College of Engineering, are here to present our paper on Indian Sign Language Recognition System. The presenters are myself, Kanchan Patil, and with my team members are Goraksha Akshada, Sangre Poonam, Vakte Mayuri, and Ada Vaishnari. Go to next slide, Mayuri. These are the contents for our presentation today. Next slide, please, Mayuri. Okay, thank you so much. So usually we know that the sign language is a natural language used by hearing and speech impaired people to communicate. There are so many people around us who are deaf and dumb, and those who are finding the difficulty in communicating with the normal people. And vice versa, we, the normal people, are not able to communicate with them efficiently. And so we are aiming to design a system, to implement a system in such a way that a sign language getcher to recognize the alphabets and digits in the sign language and translate it into the speech. The problem statement of our system is, Mayuri, please go to the next slide. To develop a sign language translation system that can translate the sign language into the text and text to speech. This system will help them to understand the language of deaf and dumb people, to understand and to execute their task easily on the daily basis. These are the project objectives. Over to you, Poonam. Please continue.
Yes, ma'am. So the project objectives are to take input as image through laptop's camera. Second one is to convert that image into grayscale image. Then converted image will be act as input for the CNN algorithm. Then we'll extract the result from the CNN algorithm. Then CNN module. Then we'll convert that extracted text into speech. Next slide, please. So our proposed system consists of 4 modules. First one is image capturing. Second one is image pre-processing. Third one is image detection and text extraction. Fourth one is audio extraction. Next slide. So the system architecture is as follows. We'll first use camera for capturing the image. Then we'll convert that image, which is nothing but the color image, into grayscale image. Then CNN comes into picture. Then CNN convert that grayscale image into binary conversion. Then feature extraction will be done. Then classification will be done. Then we'll extract the result from the CNN module. I'll explain this CNN module in brief in next slide. So this is the flowchart of our system. Next slide, please. So this is CNN. CNN is nothing but a deep learning algorithm, which is used for image extraction and image recognition because of its high accuracy. So it consists of 2 layers, convolutional layers and pooling layers. We can add those layers as per our project need. So in our project, we use 2 convolutional layers and 2 pooling layers. So convolutional layers, we can call it as a feature detector. So to detect the feature, it uses different filter, and for this different filters, it create different feature maps. And to reduce that feature maps dimension, we used pooling layer, and then this then we'll convert that 2D feature map into 1D feature map, which is called as flatten. Then this flatten array will act as input to fully connected layers. Then from fully connected layers, we can extract our text. That's all. Next slide, please. So this is the data set we have used to train our module. Next slide. So this is the image capturing. For that we have used OpenCV library to capture the image. On that we have used video capturing, and we are capturing the video, then we are converting that video into frames. And to eliminate background, we have used region of interest. And also to save the computational time, we have used that region of interest. As you can see, this is a green bounded square. Next slide, please. So in the left hand side, you can see the converted image, which is converted into color image is converted into grayscale image. For that, we have used thresholding and Gaussian blur filter. Next slide, please. So these are some characters we have recognized successfully. This is yes, we have recognized it successfully. Next slide, please. These are the numbers which we have detected: 1, 2, 4, 5, and 2 again. Next slide, please. So the conclusion of our system is to predict Indian Sign Language gesture in real time, and the above work shows we can use CNN algorithm for sign language recognition. Sign language recognition. Thank. So next slide. These are the references which we have referred. Thank you. Any questions?
Thank you so much, ma'am, for sharing your knowledge with us. Now the authors are ready to take up the queries. Ma'am,
Yeah,
thank you, ma'am.
thank you for the presentation. And ma'am, regarding your presentation, there is a small point, like you said that from the video, you're converting the video into frames. Have
Yes,
you
ma'am.
implemented this task actually? Because probably the presentation shows that you have shown some results too, correct? In what way it has been converted, ma'am? The video to frames? How you have got it?
Yes, ma'am. Because we don't have any particular function which can capture only image. So we are using like a video capturing feature from OpenCV library, and that so to get the image, we are like dividing that video into frames.
Through OpenCV, you have achieved it, correct?
Yes, yes, ma'am.
OpenCV. Okay. Ma'am, actually, one more point is that regarding CNN, you have elaborated. This is what the system architecture, what you have shown, the previous screen. Yeah, this is the one where you're capturing the gestures and find the features you're extracting, you're focusing. What are the features? Good that you've extracted the exact image, what has been captured. And in what all the features you have used to extract those things? The feature extraction you mentioned, no, ma'am. What are the
Yes.
features you extracted for doing so?
So for feature extraction, it comes into CNN module. So for feature extraction, we used three different filters. First one is loopy filter, second one is vertical filter, and third one is diagonal filter. So by using those filters, we get different feature map, and then we'll convert that means to reduce the dimension. We used pooling layers. For pooling layer, we have used max pooling. Means if we'll take 2 into 2D 2 into 2 matrix, then 2 by 2 matrix, sorry, then
It's
on
good.
that.
Uh, So fine, actually, ma'am, if if I'm focusing or if you are focusing on a face of a person, we used to say that the features are the eyes, nose, like that, correct? When
Yes.
you're just capturing for the signs, obviously you need to capture some features, which helps you to train your CNN. In fact, to train your CNN, you focus that these are all the layers what you have used, the number of layers. In fact, there also I have one small query that how many hidden layers you used to train your system in a well way, because you've got a good output I've seen. So how many hidden layers have been needed to implement that task? That is the third one of mine. But regarding this feature extraction, uh, I mean, probably I have not got a clarity through your answers. The features you have not expanded, I hope. Is it correct, ma'am?
About hidden layers, we have used like 4 hidden layers, and that feature extraction part, I'm not understanding your question, sorry.
Yeah, probably you got the point. So, okay, I'll just take, if the image is like a face, a sample I'm taking, because here you're showing the signs and everything to convert, which is to be used for the blind people. But suppose a sample, if I'm taking a face, for that the feature, what is being needed from the face is obviously eyes, nose, ears, like that, correct? So same way, when you're doing so to train your neural network, what are all features you have used? You said like we used the filters. Very good. The filters you've used, through filters, what are all the features you've extracted? Because probably you could have used some database to store your data to, correct?
Right.
And a kind of case, what are all the features mainly you focused? When these features have been satisfied, your network obviously comes with the correct solution, correct? Because we cannot feed the image directly as an input to your neural network. So fine, these are all the points which I have just expected to be conveyed. If you have any points regarding that, you can say me, ma'am. Otherwise, right.
Poonam Sankar, madam. So I have one question. What are the features you have extracted?
Yes, ma'am. We are only focusing on the hand. We are not focusing on the face. For hand, we have depth and dimensions for the hand.
Okay, you have taken only depth and dimension. Okay, which technique you are using for feature extraction? So can you tell me, ma'am, which technique you are using for extracting a feature? Madam, are you there? Hello.
Yes,
Ek
ma'am.
minute.
Which technique you have used in your paper for extracting a feature?
Hello, ma'am, am I audible?
Yes, yes.
Sorry, I had some network issue. This is done by CNN only, so we did not use like any particular method to extract that one.
Okay, okay.
I have one question, ma'am. Can you please tell me why you have chosen the algorithm of CNN? Hello?
Yes, ma'am. We have like read some papers on that. They have gotten like great accuracy because of CNN, and by using the CNN, we did not need any another algorithm. If we would have used like ANN algorithm, then I think we would have like need any other algorithm. That's why we used CNN, and for better accuracy, I can say.
Okay, ma'am. Thank you. Thank you, ma'am.
Any questions from participants? Thank you. Thank you, ma'am. Next, I call upon the next paper ID 124, titled as Convolutional Neural Network for Remote Sensing Classification by Ms. F. Hazina Mariam Fatima. Ma'am, kindly share your screen.
Yeah, sir. 1 second.
Yes.
Pooja. Hello. Hello. Am I audible?
Yes, yes, ma'am.
Yes, sir.
Yes, you can put it as a full screen mode.
Yeah, 1 second, sir.
Presentation.
Patma Pooja, share. Can you please share the screen?
Yes, ma'am.
Uh, Okay. Let me start, sir. Good morning, all. Good morning, everyone. I'm Hazina. Today, our topic was about land use and land cover classifications. My teammates are myself, Mahalakshmi, Padma Puja, B. Anita, and Kalai Chilvi, ma'am. Today, our topic was about land use and land cover classification using convolutional neural network. So, let's get into it. Next slide, please. The main abstract of this project is about land use and land cover changes. Like it have become a current central component in which the strategies for maintaining the natural resources and to understand the cause and consequences of over exploitation of soil and water resources of the land use land cover monitoring. In this project, the CNN is proposed to continuously classify the urban land use and land cover changes and comprehensively analyze the remote sensing and urban related data. The remote sensing, economic related, weather related, constructor related data are considered as an input data for the proposed CNN to increase the classification accuracy. In that, for that, we are using a satellite image as an input. This proposed CNN adequately connects the urban related and remote sensing data. Deep learning LSTM neural network model is utilized. Deep learning LSTM neural network model is utilized to urban land use land cover classification because of its advantage in long time series processing ability and artificial neural networks. This project is implemented and validated in the Python software. Next slide, please. Introduction. Land use and land cover change is the change in biophysical cover and the use of land for different purposes. So, land use and land cover changes over the time is responsible for involving the economic, social, and biophysical conditions. Such condition changes in that land occurring at various spatial and temporal levels. They are beneficial at times, but can have a terminal effect later, being the cause for the human welfare beings. Next slide, please. Human actions is the main for this unpredicted rate and magnitude and spatial scales. Land use and land cover changes streaming from human land resources. Uh, Hello, 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 hello. Am I audible? Sorry, ma'am. Actually, I was facing some sort of network issues, so that's why. Urbanization is one of the leading cause of land use and land cover changes, especially in developing countries like Nepal. With a 14.7 percentage of urban growth between 1987 to 1919. Next slide, please. The problem statement, the availability of resources as well as the dynamic and management varies considerably from areas to areas, especially in Ethiopia. Ethiopia is highly vulnerable to environmental changes. Ma'am, 1 second, ma'am. Ma'am, ma'am, I think so. The project PPT have changed. Ma'am, hello, sir. Hello.
You're audible.
Ma'am, can I present for a while? Ma'am, 1 second, ma'am. Actually, I was facing some sort of issues, so that's why. Please give me a second.
Yes, ma, you can take and you can do.
Sorry, ma'am. Really sorry for the trouble, but
It's
I
okay,
was
sir.
really facing issues.
It's okay, ma, you can present. Yes. Padma Puja?
Ma'am, I'll present, ma'am.
Yes, yes, ma. Yes, ma. Okay, okay.
Ma'am, is my screen audible?
Yes, ma. Yes, yes, yes.
Yeah, ma'am. Sorry for the trouble. I'm so sorry.
It's
Uh,
okay, it's okay.
the main problem statement is land use.
1 minute, ma. 1 minute.
ma'am.
Can you uh, make a slideshow, ma?
Yeah, ma'am. Ma'am,
Okay, ma. Okay,
yeah.
okay.
Let me
Thank
continue
you.
with it.
Thank you, ma. Thank you. Yes, you can continue, ma.
Yeah, ma'am. Land use and land car change is the fundamental problem in our country. The dynamics of land use and land car intensities and rates are changing because they are highly associated with over exploitation of natural resources. The natural vulnerability issues like climate changes, soil conditions, and terrain characteristics have also accounted for land use changes. The assessment of land use and land car changes and the drives that have direct consequences of the natural environment and social human societies. Therefore, it is very important to assess and classify the land use and land car changes based on the historical data. The objective to classify the land, which is the essential part of the creation of the standardized map, that which is helpful in the decision making and plan making process, and to comprehensively analyze the remote sensing and urban related data by using a convolutional neural network. The land use and land car maps have been used for the estimation of land use and land car changes. Ma'am, should I have to explain the literature surveys?
Ma'am,
Ma'am, should I have to explain the literature surveys?
I have to ask the session chairperson, ma'am.
No, no need of, ma'am. Let them
Uh,
Okay.
yeah,
process.
ma'am.
Okay, okay.
Um, So this is the block diagram of it. For that input image, we are taking a satellite images, and the next process is the pre-processing stage. In that, the image will undergo two different steps. For the first one is the noise removal, and the second one is the standardization. And then the next level is it undergoes a convolutional neural network. In that, 4 layers are involved: convolutional layer, max pooling layer, flattening layer, fully connected layer, and the output will be the classified map. In that noise removal layer, median filter is used. Median filter is used for the noise removal process. In that, image will be splitted into three colors in red, green, and blue. All the noises were removed separately after applying the median filter. Then the image dimensions are very high, so the pixels value will also be high. So processing time will take too long. For that, standardization is used. Image pixels values are used for standardization. In that, Z normalization is the method that we are using it. It will bring the image into a specific scale. The next layer in that, and the next will the output we attain from these two is the pre-processed output. This pre-processed output is taken as an input for the convolutional neural layer, and it undergoes all the layering, and the at last the output we obtain is the classified map. So this is the thing that I've explained it, as I've already told. This project proposes of urban land use and land car classification using CNN classifier. The satellite image is taken as an input. A median filter is used for removal of noise from the input image. Standardization is done for multi-source data for a variety of fundamental unit of vector, which is directly fed into a deep learning model. Convolutional neural network model is utilized for the urban LULC classification. Next, the median filter.
The median filter is a filtering technique used for the noise removal from images and signals. Median filter is very crucial in the image processing field, as it well known for the preservation of edges during noise removal. Why we are choosing median filter is because of this. The median filter will preserve the edges while removing the noise. Median filter is a non-linear filter, and it is efficient to remove impulsive noises. Median tends to preserve the sharpness of sharpness of the image edges while removing the noise. The pixels with the median magnitude is used to replace the pixel studied. A simple median filter has advantage over mean filter. Why we are not choosing mean filter is because of this, because it relies on a median of the data instead of mean. A noisy pixel present in an image can be significantly skew the mean of the set. The median of the set is robust concerning the presence of the noise. This filter replaces the value of the pixel by the median of the gray levels in the neighborhood of that pixel. This filtering technique is effective for both bipolar and unipolar impulse noises. This is the output of our median filter. The next step is the standardization. Standardization is a scaling method where values are centered on the mean with the standard deviation. If it will calculate the mean and standard deviation of the standard scores 0 and 1 respectively, the formula we have used is z equal to x minus mu by sigma. The standardization result we obtained from it. The next one will be carried out by Mahalakshmi. Mahalakshmi.
Good afternoon, everyone. Today I'm going to say about classification using CNN. CNN is convolution neural network. Why we have used convolution neural network means because it is more powerful compared to others, and it has more feature compatibility. And the input of the CNN takes input of fixed size and generate fixed size outputs. Convolution neural network consists of 4 layers. They are convolutional layer, max pooling layer, flattening layer, and fully connected layers. Here the CNN layer has high dimensional filter, and that is convolved with the input of that layer. And CNN use both supervised and unsupervised paradigms. Here the input of the system and output is called supervised. When the input and output is known as supervised, and where the input and output are unknown is called unsupervised models. Then the convolutional layer, this is the first layer. The convolution layer is very important layer. It contains a set of filters that are convolved with the input to generate a feature map. After the classification, it gives an output, and that is the feature map. Then next slide. Here, next layer is pooling layer. The pooling layer, here we use max pooling layer. Then that separate the input feature map into blocks and combines the feature activation. Because it chooses the map, we use max pooling function here because it chooses the maximum number of activated features from the selected input block, and the output from the max pooling layer is given as the input to the flattening layer. The flattening layer converts the data into one-dimensional array and given as input to the next layer. Then a single long feature vector is obtained by a flattening layer. This is connected to fully connected model and also called final classification model. Here, the fully connected layer or they are connected to all the previous layers. It corresponds to convolutional layers with the filters of size 1x1. Then finally, we obtain a classified map as an output. Then the next result. This is our input image. This is a river data set from an Narayan river we have took, and this is classified using CNN. The land is classified as unclassified, then water, sediment, green veg. We have classified the input into from the input image as an output feature map, classified map it is. Next slide. Then a confusion matrix. Confusion matrix is a table that is often used to describe the performance of a classification model on a set of test data for which true values are known. And by using this CNN classification, classified map is obtained with accuracy of 92% using precision recall F1 score matrix. That precision recall F1 score model is an model we can classify hyperspectral images with an accuracy of 92%. Here, the position quantifies the number of positive class prediction that actually belong to the positive class, and recall quantifies the number of positive class prediction made out of all positive examples in the data set. Then F1 square measures provide a single score that balance both the concern of position and recall in one number. The next slide. We have compared CNN with the RNN. So the RNN method classified pixel is 898, and the classification accuracy is 87.69. And CNN, we have took CNN because it's more powerful than RNN, and RNN includes less feature compatibility when compared to CNN. And CNN takes input of fixed size and generate fixed size output. When compared to RNN, CNN has more accuracy, so we have chose the CNN classification. And error rates are less than RNN. CNN. Then this is a classification accuracy, total number of pixel in RNN and CNN as we have. This is a total number of pixel given in the image, and then a correctly classified pixel is it's greater in CNN, and then the accuracy is also greater in CNN. So we have took this method, and this is a graph of classification accuracy and confusion matrix of CNN classification. And next slide. Next, it will be continued by Pooja.
Good afternoon. Advantages. LUS maps of an area provide information to help user to understand the current landscape. LULC information on National Spatial Database will enable the monitoring of temporal dynamics of agricultural ecosystem, forest conversion, surface water bodies, etc. Urban LULC classification because of its advantage in long-term series processing ability other than the CNN. Next application. Applications like flood modeling, observation of agricultural drought, climate change modeling, monitoring of environmental change including vegetation phenology, flood, fire occurrence, monitoring of carbon emission due to deforestation and forest degradation, legal boundaries for tax and properties of evaluation, like baseline mapping for GIS input. Next, conclusion and future work. In this project, classification along with the pre-processing is done by a deep learning based CNN model. By using CNN classified map is obtained with the accuracy of 90% using friction recall F1 score metrics. The classified map will be obtained by using CNN classification, which is comparatively higher when compared to another model or an. Image classification is the most important part of digital image analysis. When the image is classified, it can be used for any application. But the output of the classification algorithm is in the prediction process. This chain prediction is help to keep track of growth of the cities and help the government to plan better for the future.
Our future workers in this project, we have completed our first set of work, and we have a second set of work that which is we are currently working on it. In that thing, first we detect the change deduction, like how the particular area have changed over two particular periods of a time, and then we'll predict how the output will come. For that, we are using a change deduction algorithm as post classified change deduction algorithm. Thank you so much.
Yes, fine. So good to see your work here. Ma'am,
Thank you so much,
regarding
ma'am.
this, yeah, thank you. Fine. And I have a query on RNN you just talked about. You have taken CNN.
Yeah,
Fine,
ma'am.
RNN is mainly meant for temporal, where probably you're working with remote sensor and all those images. And small point is from where you have taken these images, from what data set you've used actually.
we have used a river data set. We have, from where we have obtained this data set is CADL data set using UCI depository.
Okay. Okay, fine.
Yeah.
Yeah. Can you go back to the working procedure of your
Yeah, sure, ma'am.
model? Here, one more thing you just focused about. Yes, this is a model, right?
Yeah, ma'am.
So, in your model,
Yes, ma'am.
actually, you specified about what's that? Specifically, it just comes with the precision and recall level.
For we are using for to find out
It
the
has come with a 92% of best result. It
accuracy.
shows
Yeah,
you.
ma'am. Yeah, ma'am.
You have just focused.
Yes, ma'am.
And how many data are the images you have taken as an input? From there, you have come to a conclusion that it is
Totally, we have
92%.
24 images we have in our data set. By comparing all this thing, we have came to a conclusion of using 92% of accuracy we have obtained.
Hmm. Hmm. It's fine. You just focus that it is about 92%. It is good. That's
Yeah,
what I'm just asking. How many images you have taken to come to a justification? This is all about 24. Okay.
yes, ma'am.
So when we are working with this kind of work, probably with that we cannot conclude that it is 92%. I believe.
Oh.
So that just gives you an idea that
No, ma'am. Actually, the overall accuracy by
whether
classifying the image as
I mean
6
your point
labels.
is like about 92% or whatever.
Yeah, ma'am. Ma'am, I
Because
couldn't
we
get you.
cannot say that the CNN is always better. Probably this case it is good that the CNN is good
The
as you're not
reason for
working with
choosing CNN
temporary data.
algorithm is because CNN gives performance well and it gives better accuracy because
Okay.
it
And other
automatically.
than that, I don't feel so. It is good. Good work. What you have done. Okay.
Yeah, ma'am. Thank you, ma'am.
And kindly try to think of all these points.
Sure,
When
ma'am.
you're coming
Sure, ma'am. I'll
uh,
try to develop all these things.
that's correct, Ma. But probably with that, we can not come to a conclusion that the 92% I understand.
Ma'am, actually, your
That
voice
is what
was
I'm talking
so
about, the
breaking. I
accuracy.
couldn't
It's
get
good that
what
the
you're saying.
92% you focus now. But when you are, that's why I just asked you, how come you said this is an accuracy just by comparing 24 images? It has to be incorporated with the processes. That's it. Okay.
Okay, ma'am. Sure, ma'am.
Is it so? Others also feels the same, huh? Ma'ams, am I audible to you all? Just a minute, just a minute. Am I audible?
Yes, ma'am,
Yes,
you are clear.
Others, ma'ams, I'm audible,
yes,
no?
ma'am.
Fine.
Yes, ma'am. Yes, ma'am.
Yeah. Hello, Azina ma'am is saying that my voice is breaking. Is it so, sir?
As for me, I think
Okay,
so.
okay,
The
fine,
network
fine.
problem for
Okay,
me
okay.
is.
Okay, fine, fine. Then it's fine.
Okay, any questions from participants?
Sir, what about publications as next step?
You can touch within the WhatsApp group, ma'am. We will
Yeah,
intimate to you.
sure,
Okay.
sir.
Hmm?
Sure, sir. Thank you, sir.
Okay. Okay.
Thank you, sir.
Yes. Please be wait. Lastly, we will share the feedback.
Yeah, sir. Definitely.
Then only you can get the certificates.
Sure, sir.
Okay. Thank you. Thank you, ma'am. Next, we call upon paper ID 296, titled as Gender Classification on Video Data Using Deep Learning Technique by Jivapriya, ma'am. Ma'am,
Yes,
Jivapriya, ma'am, please
yes,
share
yes,
your.
sir. Just a minute, sir. Sir, my slide is all visible.
Yes, ma'am. Yes. put it in a presentation mode.
Okay. Shall we start, sir?
Yes, ma'am.
Okay. Good afternoon, all. I'm Jivapriya. I'm from MCO Slang Engineering College. My project title is Gender Classification on Video Data Using Deep Learning Technique, and guided by Dr. S. Devi Mahalashmi, ma'am, Associate Professor for CSE Department from MEPCO Slang Engineering College. Today's my agenda is introduction, problem descriptions, objectives, literature survey, system design and methodology, implementations, results, summary and reference. Introduction. My project involves detecting gender from real-time video streams. Gender classification is one of the most important video analyzing tasks. It focuses effect of understanding human visualistic processing and identifying features used to categorize between male and female. It has become a popular fundamental role in social media. Automatic gender prediction from face image is highly significant for law enforcement and intelligence agencies. And problem description, number of crimes increasing daily, so it becomes to necessity to identify a criminal as fastest rate. This project used to overcome the frauds that can be take place for during vote, it's used for voter identifications, and child abuse. It can be used for surveillance at bank and residential areas. And the traditional way of processing, it's very slow. This project is deep learning technique for CNN applications. CNN nothing but convolution neural network. It's most commonly applied to analyze visual imaginary, and CNN are most prevalent algorithm. It has gained high reputation in image feature extractions. Mainly deep learning CNN will extract feature automatically, so that's why we are all using that. And objective, my objective is to detect the gender male and female from live videos. Gender classification in live video is important task. It's still challenging in real application due to motion blur, object accumulations and illuminations in live videos. And to test the classification model for its accuracy. This is my system design. Input data will give, and pre-processing step I will use, because all image converted one same array. I will be using pre-processing resize image convert to one array future scalings. Resize means it's all image should be uniform, and convert to an array. I will be use a numpy library in Python to work in with array. Future scaling, every image we will have a pixel value from 1 to 255, so we deal with a higher future values for computation. Power requirement will be high, and then CNN layers and model will be trained. Testing phases, during testing, real time webcam will be open, and gender will be detected based on the already trained model. And this is my convolution network architecture. First, input data will give 96 cross 93 means length, width, and colors, and convolution 2D layer will be used. And ReLU, ReLU is nothing but ReLU functions use dealing with non-linear functions. And batch normalization, why we use batch normalization means, if we do not normalize some data points have very high values and some have low values. So the high value may shadow the low value. So batch normalization is it's important. Max pooling, it's reduce the noise in the data sets. For example, unwanted dots like, and dropout, if we for example, if we have 100 neurons in dense layer, every time the neuron will learn well from the data. When we if we understand the training data set very well, so to avoid the overfitting, we will be use dropout. And I use 7 layers, and then I use sigmoid activation functions. This is my data set. My data sets use a includes Kaggle photos and Google images. I will be use all data set size is ununiform size. This is my sample woman data sets, and
This is my sample men data sets. And my pre-processing result is before and after pre-processing. We convert in the same size and everything. And this is my augmentation result. Evaluation model results. I will be split up into two split up 80-20 training and validation split and 50-50 validation splits. And this is evaluation metrics: accuracy, precision, recall, F1 score, confusion matrix. My evaluation metrics results is split up to 80-20 cross, and this is split of 50-50. And results, our system detects male and female in real-time videos, and it will have high accuracy during different lightings and places with different angles. My sample results output is these are all. And my summary: gender is it is directed male or female in real-time video using deep learning technique while conversion. Our system detects high accuracy with different lightings. These are all my reference papers. Ma'am?
Thank you, ma'am. Any queries from session chairs, please? Ask some queries.
The results what you have shown.
Sorry, ma'am.
Yeah. Yes, sir. Yes. Ma'am, can you go back to your in the results what you focused?
This is my result page.
Yeah. Just go back to the previous slides, ma'am. Before your reference, I think. Some sample output you have shown, right?
Yes, ma'am.
From the slides number like 23 or 22, like that.
21.
Go back. Yes, this one.
Okay.
Yes, ma'am. See, fine. It's good to see.
Yes, ma'am.
That what are all the features you've used actually? Because if you see Abdul Kalam,
CNN will extract a feature automatically.
Sarah is actually the hairstyle like women, right?
Yes, ma'am.
Ma'am, am I audible to you?
Yes, ma'am. Yes, I'm audible, ma'am.
Hello?
Ma'am, yes, ma'am, you are audible.
Ma'am, I'm audible. Huh?
Yeah, yes, ma'am.
Hello?
Wait, session chair left due to some technical issues. Please wait, please. Yes, ma'am.
Sorry, inconvenience, please.
Okay,
ma'am. No issue.
Am I audible to you now?
Yes, ma'am.
Okay. Ma'am,
Yes, ma'am. Yes, ma'am.
when you are focusing these images, probably if you see Abdul Kalam sir image, the hairstyle of him, and even the look so he's like, we cannot predict him as a man category. How come you made it actually?
We did not extract feature manually, ma'am. CNN will extract features automatically.
That's fine, ma'am. But I'm just asking you with a curiosity. Okay. I'm just asking you. In both the cases, you could have seen, if you could have seen the man and woman based on their hairstyles or whatever, He is almost resembling the hairstyle and all those stuff, as he does not have any
I
mustache or bad, he doesn't. I
I know straw padano.
Is it so?
Yes, ma'am.
I am not thinking so, because like I'm just taking a sample of Abdul Kalam sir, because as I've seen about to see, he doesn't have a beard or mustache or whatever. So if it is there, we can just make him as a man. But 100% accuracy, you've got it. That is why I'm asking. It's good that how come you've got it, because just we can also apply. No, that is what, nothing else. CNN automatically predicts means we usually train or we usually insist. These are all the things what we needed.
Yes.
So once it is being identified by the CNN, obviously it could have shown to you that these are all the data needed. And can you please get me that how come you made it done?
Image. I will climb the image and the output will show that.
Just doubts from our end, nothing else. Okay, these are all things you need to, because this is your application and you're saying that it is coming with 99.9% accuracy. For women I can accept. For a man
Okay.
it shows no, that too, the photo what you've shown as of now. I have a query that how come, with the help of what kind of gestures you have identified, saying that eyes are
We
short.
trained the image similar that, ma'am.
That is what, ma, that is what I understand, that you're using your CNN. Good. But in what way it has been taken, I'm asking. No, if you don't have idea, skip it. But at least in the near future, you just try to incorporate all those stuff. Okay.
Okay, okay.
Any questions from other participants? Yes. Thank you, Jivapriya ma'am.
Okay, sir. Thank you, sir.
Next, we call upon paper ID 290, titled as Landline Detection and Tracking Using Hybrid Deep Learning Neural Network, presented by Miss N. Saranya ma'am. Please, Saranya ma'am, please share your screen.
Yes, sir. Is my screen visible, sir?
Yes, ma'am. Yes.
Good afternoon. Myself is Sarita, and my topic is detection and tracking using a hybrid deep learning network model. These are my agendas. First problem statement. Road accidents are increasing daily, and many people lost their life in these accidents. And most of these accidents happen in highways due to overspeed and the switching off lanes. To reduce these accidents, many autonomous driving technologies have lane detection, which detects the lanes in the lanes. And detecting the road boundary lanes is a challenging task also. In recent years, many machine learning and deep learning algorithms have been deployed, but they fail
Sir, is
to
it clearly audible, ma'am's speech? Saranya ma'am's speech is clearly audible. Huh?
No, ma'am. No.
Yeah, that's what.
one second.
Ma'am, Saranya ma'am,
Sorry.
your voice is not clear, ma'am. Please.
One second. Now I'm audible, sir. Hello, sir. Hello, ma'am.
Ma'am, still I feel like. Can you increase? Can you talk now? Let me listen.
Hello, ma'am. Hello. Hello, ma'am.
Yes, ma'am, you're audible, but still I feel like it is not up to the mark. For others, they may also feel the same, it seems. Whether you are getting my voice actually,
By connecting the headphones only, ma'am.
completely it is not clear, I think.
Hello.
Can't, ma'am.
Saranya, ma'am.
Yes, ma'am. Hello, ma'am.
In,
Is it okay, ma'am?
yes, yes, ma. You can start like. Okay, okay.
Okay. My topic is lane detection and localization tracking using hybrid deep learning network model. And these are my agendas. And the problem statement is um, road accidents are increasing day by day, and many people lost their lives in the accidents. Most of these accidents happen in highways due to overspeed and switching off lanes. To reduce these accidents, many autonomous driving technologies have lane detection system in the to detect the lanes in the roads. Detecting a road boundary lanes is a challenging task. In most of the existing algorithms, in recent years, many machine learning and deep learning algorithms have been deployed, but they fail to produce a high efficiency and accuracy, and it takes a lot of time also. And that's it, Ilza. To detect road boundary lanes in a challenging conditions like heavy traffic and vehicle occlusions, etc. Second, to provide a proper understanding of the road environment. Third is to produce results with high efficiency and accuracy. Expected outcomes. Robust automatic lane detection system is developed, which works in all challenging situations. Identification of vehicles within the lane boundaries to prevent or avoid collisions with other vehicles. Third, more accurate results are compared with existing algorithms. In the literature survey, the first paper, Yongmin Co et al. Developed a lane detection system which combines point estimation and point instant segmentation algorithm. An hourglass model was obtained by keeping simple models that have different sizes, and these models were trained independently using some training algorithms and loss function. But the limitations is in the point estimation model. It shows poor performance when the lanes are congested with vehicles and uh, congested vehicles. In the second paper, they performed segmentation by applying convolution neural network. And after segmentation, the features were extracted using Huff transform and the KAT algorithms to predict the lane boundaries. And the limitations is it shows poor performance when dealing with shadow occlusion, deprivation in the landmark, vehicle occlusion, etc. In the third work, they proposed a camera-based deep neural network for detecting the lane images in three-dimensional view. The authors applied a bird's eye view to view the lanes in 3 dimensions and to segment the image into divisions based on the lanes. Then the segments are combined into a full lane by embedding features into the into the model. The limitations is it doesn't it unable to detect links which are not parallel. In the proposed system, most of the methods focused on detecting the link from one single image, and it leads to unsatisfactory performance in challenging situations and extremely bad weather situations such as heavy shadow, serious vehicles, and so on. So that in the proposed system, the lane is detected by using multiple frames from a continuous driving scene. A hybrid deep architecture by combining the convolution neural network and the recurrent neural network is proposed. This is the system design. The input is given to the encoder CNN, and downsampling is performed. And then given to the hybrid model of convolution and LSTM network, the features are extracted and the lanes are filtered, and in the decoder CNN, deconvolution and upsampling is performed, and in output the lanes are predicted. So the modules are encoder CNN, decoder CNN, and convolution and LSTM module. In the encoder CNN, the encoder CNN it consists of a sequence of convolution and pooling layers for representing the image frame and extracting the important features from the image. So the streaming video is split up into frames and are provided to the encoder CNN. The encoder CNN processes the input data and generates the feature descriptors for each frame. So the generated features are then given to the LSTM model for detecting the lane regions. In the decoder CNN, deconvolution and upsampling are used to reconstruct the input and to reduce the error between the predicted output and the targeted output. So this is the encoder and decoder network. The convolution LSTM. So in the convolution LSTM, here double layer LSTM is applied with in one layer the features are extracted, and in the other layer the features are integrated. So to reduce the time and computation, so we use convolution LSTM. So these are the input gates. In the input gate, we are using a sigma.
Saranya ma'am, and background so much noise is there, ma'am. So much. Okay, ma'am. Okay, ma'am.
In the sigmoidal activation function and tangential activation function is used. So the input is information from the previous event state and current input, and the output is input gate output and candidate. For big the sigmoidal activation function is used. Here the input is information from the previous event state and the current input, and output is for big gate output. And the output gate decides what the new hidden state should be, and it is passed to the LSTM cell. Here the input is newly modified cell state and cell state output, and output is new hidden state. So for detecting the lane, the data set used is two simple lane data set, which is collected from the Brazil website, and the resolution used is 128 cross. So it consists of 3,626 sequences of image, and each image contains 20 frames, which are collected in 1 second. So to label the image, for every sequence, 20 times 30th image is labeled with a ground truth. So the features are first abstracted using the CNN encoder, and then in the convolution LSTM is used to process the features, and then it's given to the decoder to pick the names.
Whether we are audible to you actually. In fact, beginning to end, it is like Obviously, it was not audible. As I said,
Lots
only
of noise.
yeah,
Yes,
lots
ma'am.
of noise. Even ma'am's voice is not clear.
Sorry, ma'am. Actually, there are some construction workers going in the complex, so these are the results.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you. Now, authors are ready to take up the questions, ma'am.
Actually, from her end, I couldn't get whatever she
Yes, sir.
concluded.
Yes, yes, yes. We are not able to understand the what is you are telling, ma'am,
In
actually.
fact, what I just found is that she is just has gone for a method for implementing zone boundary deduction. That's it. And she focused that there are many algorithms, machine learning algorithms, which has done this task, she said. But what she focused and what she has done, Saranya ma'am, is this, do you feel that there is a sound from your end?
Sorry, ma'am.
That is what a problem, ma'am. Probably she couldn't get what we are talking. In
Yes,
fact,
yes, ma'am. Saranya, ma'am, make sure that next time if you do a presentation, make sure that you sit in a place where there is no noise like this. Okay.
Okay, I'm sorry.
We are not able to understand what you are saying. Neither you are not able to understand what we are saying.
correct, exactly.
Okay, ma'am. Okay, Saranya,
Thank you,
ma'am.
ma'am.
Thank you. Thank you.
Thank you.
Now I call upon Vignesh, sir.
Yes, ma'am. Can you
Uh,
hear me, ma'am?
yes, 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 sir. Yes, sir. Yes,
Okay.
sir. You can present the paper. The paper ID is 309. 309. Okay. Yes, sir. You can present, sir.
Ma'am, I think it's 302.
Yes, yes. It's
Yes.
302.
Okay. I'm presenting my screen, ma'am. So can you please acknowledge if it is
Yes, 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 sir. Yes, sir.
so is my PPT clear, ma'am? Shall I proceed, ma'am?
Yes, yes, sir. You can proceed, sir. Is it clear? Yes, yes, yes.
Thank you, ma'am. So
Okay.
this is my our project. So pedestrian safety system with crash prediction. So the authors are Maladi ma'am, AP IT department from FCO College, and Kalpriya ma'am, associate professor CSE department from FCO College, and myself Vignesh Aranan, IAP CSE from Ramco Institute of Technology. So the outline of my presentation is first I'll tell you the introduction, and then the literature review, objective, methodology, results and discussion, scope and novelty, and then the references. So introduction about our project is, so every year we are facing frequent road accidents. So I have given like random statistics like every year nearly 1.5 million people are dying in traffic collisions across the world, and mostly in road accidents 23% are through pedestrians, that is the people who are crossing the roads very carelessly. In the United States, in the year 2020, 5,987 pedestrians were murdered or they were dead in road accidents. So it was really a very large count, and one pedestrian is being killed every 1.5 hours on average. So we have some literature review over all these things, and what are the innovations that has been recently in this particular domain is, so there are numerous automakers, that is like automobile industry. Uh, so they are actually constructing and they are installing active pedestrian safety systems into their vehicles. So in many vehicles are being provided with such safety systems. So what is the main motive of such safety systems is they are trying to reduce and eliminate the pedestrian collisions or other accidents as well. So what the sensor system will do, that will be keeping tracking of all the pedestrians in the front of the vehicles. So the main motive of such techniques is to estimate and reduce the accident risk, such that they can reduce the collisions and accidents. These are many literature review, so out of which I have just tabulated only a few things. So first one is like a haptic feedback to assist bus drivers for pedestrian safety at road speed.
Sir, Vignesh, sir.
Yes, ma'am. Yes, ma'am.
Lots of disturbances there, sir, happening.
Ma'am, 1 minute. 1 minute. இல்ல டைம் முடிச்சாங்க கிளம்ப முடிச்சாங்க. So these are some of the literature review. So first one is haptic feedback system to assist bus drivers for pedestrian safety at low speed. So what they have proposed here is they have proposed a technique like ADAS. So that is going to give some haptic feedback. Haptic feedback in the sense it will give some touch and feel sensation. Maybe the steering may get vibrated when we are going to face an accident, such those things. So likewise they get designed. And second one is an active safety system for low speed bus braking assistance. So in which they are going to use an algorithm like obstacle avoidance algorithm that is going to track the distances and it is going to give some alarm. And the next one is active pedestrian safety and automatic braking and evasive steering. So in which they have tried out an automatic evasive steering in more than 40 trials using steer algorithm. So in that steer algorithm, they are going to identify individual objects and they're going to obtain the motion of the object that has been identified. And the last one is the automated vehicles and pedestrian safety, exploring the promise and limits of pedestrian detection. So in which they are going to try to identify two or more persons, not only a single pedestrian. They are going to try to identify two or more pedestrians and they are going to detect such that there won't be any collision. So these are the main objectives for our projects. We are trying to avoid the traffic collisions due to the unexpected behavior of pedestrians. And here we are developing an augmentation function. So this function is mainly for predicting the crash risk for the active pedestrian. So we are trying to predict the state of each pedestrian into three types, such as they may be walking or they may be standing at the main roads or they may be in a running state. And then finally, we are trying to evaluate the crash risk that calculates the minimum detection range. So this is our proposed methodology. So our augmentation function that has been proposed, it is going to have three main functions. So one is pre-crash scenario, and then vehicle trajectory, and then pedestrian trajectory. So along with this, we are going to also add up the Markov model. So that is going to find out and it is going to predict the state of each and every pedestrian, maybe into this three classification. And last one is we are going to use the Monte Carlo algorithm that is going to evaluate the crash risk. So this is our actual system architecture. So input from the sensor and then processing a minimum detection rate, pre-crash scenario for the pedestrian crashes, and then pedestrian trajectories and vehicle trajectories, and then estimation of crash risk. So this is the pre-crash scenario. So here we have just given a graphical representation of how a pedestrian is going to cross the road and the vehicle. So here we are going to track all the distances and all the angles, maybe the length and width of the vehicle and pedestrian who is standing aside the road, and the distance between the pedestrian and the actual vehicle. So here we are going to have some benchmark of the angles, like we are going to have the angle from 20 degree to 60 degree. That is when we are seated at the driver's seat, we cannot go from 0 degree angle. We are going to take from 20 degree angle to 60 degree angle. And we are going to take all the parameters like vehicle acceleration, distance, time to reach the collision by car, and time to reach the collision by the pedestrian. So all those values we are going to trace it out, and we are going to put it in a and substitute on those values. So when we are substituting it into all those values, so we'll be getting some binary values as zeros or ones. So that is going to determine, like, see if the pedestrian was struck by a car or not, and the function variable is set to 1 if the pedestrian was hit. If he is not hit, it will be set to 0. So after this, we are going to go to the next one, that is the vehicle trajectories. So here we are going to calculate the vehicle speed. We are going to use the formula with the vehicle speed of 20 kilometer to 60 kilometer with a calibrated value of 40 kilometer. So here the driver can apply the vehicle's maximum deceleration of 9.5 meter per second for emergency braking. So such that we can reduce the possibility of pedestrian collision. And here, the next one is the pedestrian trajectory. So the first step is to categorize the pedestrians into three things. They may be children or young people or elderly. So based on age group, we are going to classify. 5 to 9, they are children. 10 to 59 is they are like normal people, and elderly people is greater than 60. So here the main objective is, so we are going to quantify and access the pedestrian space, which is divided into three states, that is whether they are running or walking or standing. So by measuring the speed of all the aged people, like child, young or old, so then we are evaluating the speed of young people, and we are going to have the step size value that is calculated as 1 or 0.57. So the last one is like estimation of crash risk. So here we are going to calculate the likelihood of the collision. So here we are going to use the Monte Carlo technique that is being used. So this function, it is used to calculate the distance between the pedestrian and the collision zone. So as well as it is going to calculate the time it would take for vehicle to cross the collision zone. So if the pedestrian is in the particular collision zone and the time it is required is also greater, then normally we can predict that okay, there will be some collision. So to identify that, we are going to use the values like DPED, that is the distance of the pedestrian, and TTC vehicle, that is the time to crash. That values we are going to track. And when the particular track is exceeding the minimum detection range, then it is being the final output we can predict as the vehicle should actually adjust to the other lane, or it should decrease with the speed of the vehicle. So the particular vehicle will be getting the notifications like it will be, in case it will be some, we need to provide some thing like it should automatically reduce the brake, or it should move to the next vehicle lane. So this is the process of estimation of crash risk. So we are going to identify the speed and location, identify the state, speed and collision by Markov model, and estimate the crash risk by Monte Carlo algorithm. So depending upon our mathematical calculation, so we have come to a little bit of conclusion. Like, so when we take some parameters, like if for a children in a walking state, and we are going to fix the field view of 50 degree and the detection range of 40 meter, then if the accident risk probability is more than 0.1, then we can say that the driver should change his vehicle's lane, or he should lower the vehicle speed. So similarly, if the another simulation like for the crash risk graph is for old people in running state, so then we need to give a conclusion like the crash risk can be reduced by changing the vehicle lane, and hence the accident can be avoided. So the scope of this particular project is, so in this analysis, an augmentation mechanism is being used, and it is, we are proposing to have an efficiency in detecting the collisions. And in future, we may expect to use accurate head and body poses of the people, as well as the other additional data, and we can go for some convolution neural network motion contour image-based descriptors, and or we can go with some SVM methodologies. So these are the various references that we have cited. Thank you.
Thank you, sir. Thank you, sir. Ma'am, any
Thank you,
questions,
sir.
ma'am?
Yeah. Sir, this is actually a wonderful work. What is being needed for the present scenario?
Yes, ma'am. Thank
Okay,
you. Ma'am.
but the augmentation part, how you have done it? Have you started an implementation of this? Work what you have shown as of now?
Ma'am, actually, we have done with more mathematical things, ma'am. We are trying to add those formulas in MATLAB, and we are just trying to get some results, ma'am. So not first what we have did is we are creating some random scenarios, and we are trying to trace down values like vehicle acceleration, what may be the distance request. We are when you see this particular scenario, right? We are generating some values, ma'am, and based upon that, we are trying to get some prediction values.
So as of now, you're trying the work, correct?
Yes, ma'am. Yes, ma'am.
So you've started the work, and
Yes.
MATLAB, you're doing all those things. Like any other stuff you're using for doing in this implementation, like because practically when you are taking some random scenario, we find like if it has been, as you know well, the vehicle speed and everything has been properly monitored, it will be, most of the accidents will be avoided.
Yes,
But certain scenario, if the driver is not, in a proper condition, by the case also, even the car is being in a proper condition, there may be a possibility of getting these accidents.
Yes, ma'am. Yes, ma'am. Sure.
Correct, sir. Have
Yes,
you
ma'am.
considered all those factors here? No.
Ma'am, depending after getting all those parameters, what we are trying to do is we are trying to automate the motion. So if a particular person is detected, even though the driver is aware or not, we need to automatically provide a braking system, or we need to alternately go to the next lane. So that is what. But automatic braking, that is possible, ma'am. We can go ahead, but changing the lane, I don't know whether it is feasible or not. It has to be done by the driver.
No. I'm not asking that, sir. Actually, what you have done is so far, it is really good. I'm just asking that. Okay, fine. And the driver, whether the variation is there in speed, has it been monitored through your system? Because if the driver is not in a normal position, normal in the sense if he has taken a drink or whatever,
Yes,
he couldn't drive properly. By the case, there may be a variation in the speed.
Yes,
That
ma'am.
could have been also observed, no? Has it been kind of parameters, has it been incorporated? I'm asking.
No, ma'am. Actually, what we are just trying is we are going to calculate the vehicle speed between 20 kilometer to 60 kilometer only. Within this range, actually, we are calibrating.
Okay, sir.
But
Very
in
fine.
some cases it may exceed. Maybe if a drunken driver, he can go at 60, 80 kilometers.
These are all the things you may consider when you go for the next level implementation.
Yeah, sure, ma'am.
Okay.
Sure. See, understand, ma'am. Understand.
Thank you, sir.
Thank you.
Thank you, ma'am. I thought so. We come to the last of our session. Now I request our session chair to summarize the session. Ma'am, please.
Yes, sir. So, thank you so much for making me to be here with this session. In fact, most innovative ideas, probably the last session whom I met, this is really a fantastic work, I just felt. But it has not been named. Vignesh sir has not been named in the sheet which has been shared with me, the pedestrian safety system with crash prediction. And the first presentation is by Indian Sign Language Recognition System by Kanchan Patel ma'am and the group. They presented there, and few of the queries what you have raised, what you have raised. It's only, I mean, as a whole, I'm just narrating that whatever the queries, whatever which is being raised from my end, just for sharpening your final product or a work. That's what. If it is being implemented in the form of a product, it's well and good. Otherwise, it has to be considered to shapen your system. That's it. So the Indian Sign Language Recognition System, as we have suggested, few points need to be considered, like the features. We just asked about the features, and those things need to be incorporated. Azina ma'am and the team, they've just come with a paper, Convolution Neural Network for Remote Sensing Classification. There we have felt like, I mean, of course, all the papers, as I mentioned, that the presentation point of view, it is very fine. And even this Convolution Neural Network for Remote Sensing Classification, they have done a good job. And we just add a few points about the CNN and RNN. Obviously, the reason for CNN, they have justified in a very clear way. And the third paper, what we have taken by Priyadashni ma'am, Kavipriya ma'am, and Saranya ma'am. And the paper is about lane line detection and tracking using hybrid deep learning neural network model. But unexpectedly, the content was good, but I couldn't get what she has conveyed. So we couldn't clarify certain, queries, what I felt during her presentation. So this is, as ma'am said, it need to be considered by the presenters when they are coming for this presentation. They need to incorporate all those points, because this is kind of knowledge sharing session we are doing. So the next presentation by Jivapriya ma'am is gender classification on video data using deep learning technique. As we have suggested, kindly incorporate certain points which are mentioned to classify the male and female. The features what you are considering, you please be aware of such kind of thing. This is what we felt, and as a whole, if the session is fantastic, and probably whomever is here would have gathered a lot of points, the knowledge shaping has been done during this session, I feel. Thanks for the opportunity. Thanks, Anusha ma'am. Thanks, sir and ma'am. And thank you for the opportunity. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am. I call upon any participant to share the feedback. Anyone willing to share the feedback? Authors? Authors, you can share your feedbacks about the session.
Madam, kindly share the feedback link.
Yes, I'll share it. Okay. If there is no other feedback, like you have to fill the feedback link, then only you'll be getting your certificates.
Excuse me, others, please. All the others are requested to fill the feedback, then only we can get the certificates. Please, all of you, please fill it. Even one of you may be present here. Please request all others to fill it.
Thank you, sir. Thank you, ma'am.
Thank you, ma'am. Thank you very much.
Thank you, ma'am, for your great participant and great knowledge sharing, ma'am. Thank you, ma'am. We are very happy that we are blessed to be here, ma'am. Thank you, ma'am.
It's my pleasure too, ma'am. Thank you so much
Thank
for all your nice coordination too. Thank you so much.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
The feedback link has been posted in the chat box.
All the participants are requested to fill the feedback, please.
All the authors have to fill. It's not for a paper. Each person in the paper has to fill the feedback link. Make sure that all the participants fill the feedback. Yes, thank you. Thank you. Thank you. You will be getting your certificates within 3 to 4 days. Okay. If you have any queries, you can post it in the WhatsApp group of our session. Okay. Thank you. Thank you.